And regarding last lecture's last example, partitioning stairs, you could, in fact, decompose this problem into smaller problems, as we did before. And one of the ways to decompose this problem is use at least one M or don't use any M. So you have two cases. So when you are partitioning stairs with the maximum step size of M, you can either use M or not, all right? So in this case, you can call partitioning stairs N minus M and M. Because you're using at least one M steps, that means you need to reduce the total number of steps N into M minus M like this. And because you are using more than one M steps, you just put M here. In other case, if you are not using any M, then you need to call this function with this parameter. So you're partitioning stairs, the same number of stairs N. However, you need to reduce the number of maximum steps to M minus 1 because you are not using any M steps, okay? And when you think about base cases, there are three base cases where N becomes 0, N becomes smaller than 0, meaning N is negative, or N becomes 0. So try to think about these three base cases and how to decompose this problem into these two cases, and you can implement this problem, all right? I already gave you the solution, so you can think about it. Any questions regarding this problem? All right, let's move on. So today we are going to talk about test-driven development. So what is test-driven development? It is abbreviated as TDD. And in fact, we are practicing TDD now. Maybe you saw this kind of comment in the homework problems. Let's have a look at the first part. This part describes the functionality of this function. So this product function returns the product of the first n terms in a sequence. So this describes the functionality of this function. And also, you can describe what the parameters are. So n signifies a positive integer, and this term indicates a function that takes one argument to produce the term, right? So this is the first part, description of the function. And the next part is a set of examples of input and output. So this symbol means when you pass 3 an identity, then the output is going to be 6. Another example is when you pass 5 an identity, the output is going to be 120. All right. So these are some examples of input and output. And you might have run this part. And when your implementation is not correct, then it gives you the warning. So the expected value was 6. However, it produced 0 like this. Expected value was 120, but got 0. So by using this expression, you can test your implementation. And these are some so-called test cases. And a general procedure of software development is you first design your software, and then you implement by programming some codes. And then you test your implementation, whether it is correct or not. And if your test cases are not fully passed, then you go back to the design process and update your design. So that is a basic or general procedure of software development. However, in real world, this could be somewhat very difficult because when you make a big program, then going back to the design process again can be costly. So rather than doing this procedure, what we do is we first design, and then we design test cases. And by designing test cases, you can come up with some design update ideas. And then you go back to design process again and design again. And if these test cases are satisfactory or good enough, then you start implementing. However, sometimes your implementation might be good enough or your program might be very dirty. In those cases, you do something called refactoring. You make your code clean. And then using your clean code, you test your implementation once again. So this is a new cycle or procedure of TDD, okay? So in our homework, I gave you the test cases. However, when you are implementing your own program, what you need to do is just write down your test cases first and then start implement, okay? That's the core of TDD. And why do we care about TDD? What is the advantage or pros of TDD? TDD makes you fail early. You can find your faults early in the early stage. That means you could reach better design. And you can divide your program into smaller pieces. That means you can make your program modular. And because your program is modular, you can use some part of your program in other parts of programs. And it enhances the code's usability. And because you already gave you all the description of your functions, you might spend less time for documentation. And documentation is really important. And you can make your test process automated. That means you can debug your program easily. And there are some disadvantages of TDD. However, these disadvantages are somewhat controversial. Some people say it reduces the productivity because you need to write down all those test cases. You can reduce your productivity. However, because you can save some time for documentation, I'm not sure if the productivity really reduces. And another disadvantage of TDD is it is quite difficult to learn at first. However, as you can see here, writing down test cases is not that difficult. All right, you just need to follow this procedure. That's all you need to do. So it's not that difficult, I guess. All right, so that was about test-driven development, and I'm going to describe test-driven development in more detail in the live coding session. Are there questions up to this point? Cool, let's move on. And from now on, we're going to discuss what object-oriented programming is. And some of you might have learned this concept already in the first freshman courses. Here, we're going to view this in respect of Python. OOP is a method for organizing programs by bundling together information and related behaviors. What does it mean? It is an abstraction between the use and implementation. I'll give you an example. Think about making games. There are multiple agents interact within the game environment, and your character, other people's character, NPCs, monsters, and etc. So there are many agents, right? And it would be suffering to implement games only using functions. However, we could represent each agent, like your character, other people's characters, NPCs, monsters, as objects. So object is somewhat abstract concept. We implement this object as a class. And you can just think of a class as a new data type. And this new data type serves as a template for all objects whose type is that class. All right. And I'll explain this in more detail in the live coding session. And why do we care about OOP? There are three main advantages. The first advantage is encapsulation. It offers abstraction barrier between the use and the implementation. I told you about this. And there is second advantage, that is inheritance. You can reuse your code by using hierarchy. That is what inheritance is about. And the third advantage is polymorphism. You can use the same function or method that gives different functionalities. So poly means multiple or many, morphism is shape. So even though you have the same function name, it will give you different functionalities for different objects. Okay, let's have a look at some codes. So this is our class collab. All right, let's first have a look at how we can define a class. Defining classes in Python is quite easy. You just need to put class keyword here and the class name. So let's assume that we are implementing some players for a game. And rather than start implementing this class, I'm going to write down some test codes first. This class represents a player in a video game. And I'm going to give you some test cases. What I want to do is, I want to make a warrior. And when I want to make a warrior, I call this class and pass some names. Let's say our warrior's name is Mario. And when we call this part, call this expression, it does not produce any output. So we just move on to the next line. And when we call warrior.name, it produces, its name is Mario. In the next case, if I call warrior.health, it returns 100. Warrior.experience, it returns 0. And there is a function, warrior.damage, 10. It returns nothing. And if I call warrior.health again, then it says its health is reduced to 90. It was originally 100. However, after it got damaged, its health becomes 90. And there are other functionalities like warrior, boost. And after warrior health, it's going to be 95 because we boosted the health. And one other functionality of this player is attack. Let's say attack 5. And after this, warrior experience becomes 5. All right. So these functionalities are what we want to implement through this class, okay? When you look at these test cases, one thing to note here is this is how you can create a new instance of player. So I told you that player is a template for some objects. It could be your character or NPC or other people's characters or monster. So this is just a template. So from this template, you need to create an object, concrete object. That's what, this is how you can create an concrete object. And this line explains that. All right. And as you can see here, this dot notation, you can access to object attributes. I'm using this term attributes. This player has attributes called name, health, experience. All right. And another thing to note here is you can call a function, however exactly it is method. I'll explain the difference between function and method. All right. Okay, let's implement these functionalities. First things first. How can you create an object or instance with this class name player? That's through this init function, init method. So here you pass self and then name. And let's pass also default parameter experience. So we can call this function, this method, a constructor because it constructs a new instance of the class player. All right. And we're going to assign a list of instance variables or attributes. So this one should have name. Then we say self.name is name. So self's name is going to be this passed argument name. And this self's health is by default 100. And this self's experience is going to be this past experience. All right. So this is how we construct, how we implement this constructor. And what we also want to do is self damage method. So in this case, we pass self and amount. And the functionality of this damage method was to reduce the health of this instance. So we are going to reduce health by the given amount, like this, okay? And implementing attack is going to be quite easy. We pass amount as well. And this attack increases our experience, right? And the boost method increased our health, right? So this is the implementation of this player, all right? Let's run this part and try play with this code. Let's say it's going to produce the same functionality as we expected. And here, you might be confused with this self argument, right? In fact, I told you that this player is a template. And this self indicates the actual instance. So in this case, W is going to be self. So when we call print W dot damage and pass 10, here we do not pass self. When you use this dot notation, Python automatically binds the self to W. All right. However, so when we print alpha again, it's going to be 9, right? However, sometimes you want to be explicit about this self. Then what you can do is you can call this player dot damage and call this damage method. In this case, it's actually function. Then you pass self here, W, and damage, the amount of damage, 10, like this, and print health. And the health reduces to 70. So basically this one does the same thing as this one. So if that notation is applied, then self is automatically bound to the actual instance. However, if you want to be explicit about this, then you call this player the class name rather than the instance and call this damage function. In this case, you need to pass the actual instance W like this. All right. So when we actually compare the type of player dot damage and W dot damage, Python says player dot damage is actually a function. However, W dot damage is a method. So what is the difference? A method means some functions bound to specific objects. Methods are bounded to specific instances. However, functions are not bounded to specific instances, but these are general functionalities. All right, so these are differences. So why is it so? When you call this damage method, the functionality of damage is different from instance to instance. Let's say we have another player, Jeff. After doing these operations, Mario has different amount of health. However, player Jeff still have 100 health, right? So when we call P dot damage 10, this damage will have different functionality than this W dot damage, right? Because this P dot damage is bound to this P, right? So the functionality of this damage method is different from instance to instance. So that is the reason why we differentiate function and method. All right. So the keys, each instance has its own attributes. And because they all have their own attributes, like player P and W have different like health or experience, when we call this attack method, it will have different effects on different instances. Okay. So any questions up to this player class part? All right. And today's first PPP exercise is going to be have a look at this clothing class and read these test cases and try to implement this part.